In today's lesson, we are going to start on Unit 0B, and we are going to work first on factoring polynomials. So, for example, what you will see first is something that looks like this problem. Factor the following: 9x to the fourth plus 15x squared plus 12x. And you may be thinking, what does factor mean? What in the world is with this expression? So a little hint is that we are going to factor this by finding and writing out the prime factorization for each term. So what we're going to be doing is finding the greatest common factor. So you might remember this as GCF. What we're going to do is we are going to look at every number in this term, 15, 9, and 12, and we're going to say, okay, what is the biggest number that we can divide all three of these terms by? The next thing we're going to do is we are going to look at the variable. So we have x to the fourth, x squared, and x to the first, or just x. So we're going to ask ourselves, how many x's can we pull out of this? So we are trying to find the greatest common factor, although in previous years you have just found the greatest common factor using numbers. Now that we have learned our exponent rules from Unit 0A, we're going to be able to also find the greatest common factor of variables. So when we look at the greatest common factor, here, let's see, I'm not sure why this isn't switching to the next screen. Give me just a second. All right, so there we go. All right, the greatest common factor. So what we're going to do is we're going to figure out, okay, this first term, 9 times x to the fourth, what does that really look like? And if we write that out in expanded form, 9 times x to the fourth, well, 9, if we write it as a prime factorization, is 3 times 3. So that's going to take care of our 9. X to the fourth means we have x times x times x times x times x 4 times. Okay, let's take a look at the rest of these terms. We've got 15x squared. So 15, prime numbers, is 5 times 3. Okay, the prime means the only numbers that we can multiply to get that number is prime numbers. So they don't simplify at all. So we've got 5. The only numbers we can multiply to get 5 is 1 and 5. 1 and the number itself, prime number. Same with 3. 1 times 3, prime number. And then we've got x squared, which is x times x. And lastly, we have 12x. So we have 12. So what are my prime factorizations of 12? Well, for 12, we actually have 1 times 12, but 12 can be 2 times 6 or 3 times 4. So we know that 6 is not a prime number because 6 can also be 3 and 2. Same with 4 can also be 2 and 2. So as you can see, either way we do it, 2 times 6 or 3 times 4, we end up breaking it down into 3 times 2 times 2. Okay, so how do we find the GCF from this? We are looking for the biggest number. As you can see, number-wise, 3, 3, and 3 is our biggest number we can take out of each. So 9 and 12 cannot use that 5, and then 9 and 15 do not have a 2. So we're going to use 3 as our greatest common factor just for our numbers. Then we're going to say, okay, what is the maximum number of x's I can take? The top number, 9x to the fourth, has 4 x's. 15x squared has 2 x's, and 12x only has 1. So we can only take 1 x out of each of those. So you can now see in each row, we have 3 times x, 3 times x, and 3 times x. So that means our greatest common factor would be 3 times x. All we are working on today is finding that greatest common factor, which we now know is 3 times x. Once we find it, step 2 is going to be to divide each of those terms, the original term, 9x to the fourth plus 15x squared plus 12x, we're going to divide that by our greatest common factor. Okay, so again, 3x is going to be our GCF, or our greatest common factor. We're going to do this one step at a time. So we're going to use our exponent rules we just learned in the last unit. 9x to the fourth divided by 3x. This is a hint, it's flashing for you. When there's no exponent next to a variable, there is a hidden 1. Remember, x to the 0 would just be the number 1, so actually x wouldn't be there. So if there is not an exponent, you can assume it is a 1. So what we're going to then do, 9 divided by 3 here, 9 divided by 3 would equal positive 3. Then we're going to use our exponent rules. So dividing exponents, we're going to subtract. So when you divide exponents, you're going to subtract. So 4 minus 1 gives us a 3 as an exponent, and we still have this x as our base. Okay, so when you divide powers, again, you're going to subtract. You get 3. 9 divided by 3 gives you the 3. X is going to stay. 4 minus 1 is 3x to the third. That's our first term. Now we're going to focus on this middle term here. So 15x squared divided by 3x. Again, 15 divided by 3 would be 5. And then we would still have our x. 2 minus 1 is 1. So it would be 5x to the first, or 5x. I will show you those steps here again. Hint, when there's no variable, there's a hidden 1. So again, 15 divided by 3 is 3. 2 minus 1 is 1. So we get 5x to the first, or just 5x. Lastly, 12x divided by 3x. So 12 divided by 3 is going to equal 4. Then we've got x to the first divided by x to the first. When we divide exponents, we subtract. So 1 minus 1 would give us x to the 0. And here's where I was telling you x to the 0 is 1. Any variable raised to a, or number raised to a 0 exponent is 1. So 4 times 1 would equal 4. Just the number 4. I'm going to show you that again in the next step. 4. So the greatest common factor, we pulled out a 3x. When we pull out this 3x to the front, what we're left with is this term at the bottom. So 9x to the fourth divided by 3x left us with 3x to the third plus 5x plus 4. And if you wanted to be able to check your steps, you would simply multiply that back out. So let me show you what that looks like right here. So again, what I was saying was you could multiply this back out using your exponent rule. So you could do 3x times 3x to the third, 3x times 5x, and then 3x times positive 4. And you would get back to your original equation. So let's do another example. This time we're going to factor by finding the GCF of 4x to the fourth minus 24x to the third plus 8x. So the first thing we're going to do is find the GCF for each term. You can write it out expanded form if you would like to. In this case, what I like to do, you're going to find your numbers here. But in this case, you know that we can take two 2's from each of these terms. So 2 times 2 is actually 4. What I usually will do is look at these numbers. I've got 4, 24, and 8. And I'm going to say, okay, what's the biggest number I can divide by? I normally take the smallest number, which would be 4, and say, okay, can I divide 24 by 4? Yes. 8 by 4? Yes. So 4 would be my number. And then I would look at my x. So I've got x to the fourth, x to the third, and x. So I can only take at most one x. So you can expand it out like I have written here for you, or some of you might be really good at just looking at the numbers and knowing your multiples of 4, or good at finding the GCF. So in this case, the greatest common factor, like we said, was 2 times 2, which is 4. And then we can take 1x. Again, we're going to have 3 different division problems going. We've got 4x to the fourth divided by 4x. We've got negative 24x to the third divided by 4x. And we've also got 8x divided by 4x. 3 different things going on. Again, I'm going to click through these just so that you can see each of the individual problems. So 4 divided by 4 is 1. You don't typically see that 1 written out. With division of exponents, you subtract. So 4 divided by 4 is 1. There's an imaginary 1 here. Okay, 1x. And then we have 4 minus 1. So this would actually end up being x to the third. Now we're going to do the middle term. So 24 divided by 4 give you 6. 3 minus 1 would give you 2. So we get 6x squared. And then 8 divided by 4 is going to give you 2. X to the first minus x to the first, divided by x to the first. So 1 minus 1 is 0, so we get 2. So again, we pull out our GCF, which was 4x, and we're just going to rewrite everything else that was written when we divided by 4x. I'm going to switch to a few more example problems with you. So we're going to go ahead and find, I'm going to do this a little bit faster. We're going to find the GCF of 6x squared plus 9x minus 12. So I'm going to circle my numbers. We've got 6, 9, and 12. 6 cannot go into 9. So I'm going to say, okay, what number can evenly divide 6, 9, and 12? That number is going to be 3. I'm going to go ahead and pull that out. So 6 divided by 3 would give me 2. And I'm going to rewrite this x squared. I'm going to rewrite my plus sign. 9 divided by 3 gives me 3. So 3. I did not do anything with my x values. And then 12 divided by 3 would give me 4. So I'm going to write my minus sign and then 4. In this case, our last value, which is 12, does not have an x, so we actually cannot pull out any x's. So our GCF in this case would simply be 3. Let's take a look at this one on the